Hello, everyone. My name is Gerard Gatch, and I'll be the moderator for today's webinar on the topic of automation of twin column chromatography systems, insights into the new process control software. We understand that you have limited time and came here to hear the content, so we'll forego formal introductions of our company until the end of the webinar. Just a few housekeeping notes, and we'll commence with the presentation. Today's seminar is 30 minutes long, leaving time after the formal presentation to answer any questions you may have. This presentation will walk through the automation of twin column chromatography systems that has similarities between batch LPLCs and HPLCs. However, the industrial GMP compliant control platforms on a YMC Contichrom Twin System have enhancements, and the format is uniquely user-friendly. This 30-minute webinar is intended to provide the highlights of this automation platform. The presenter is Dr. Kathleen Milbachler. Kathleen is an expert in the field of multi-column process chromatography and was instrumental in the development of the twin column systems platform technology at YMC Process Technologies. She has worked for more than 15 years in the area of process chromatography, including at different levels as senior researcher in the pharmaceutical industry at Bristol Myers Squibb, Eli Lilly, and Pfizer. She has taught undergraduate courses for chemical and biomedical students in the Department of Chemical, Biological, and Pharmaceutical Engineering at the New Jersey Institute of Technology. Starting in 2014, Dr. Milbachler holds a director position at the AICHE's Separation Division. She's also a member of the scientific community, a committee of the International Symposium on Preparative Chromatography since 2007. Kathleen holds doctoral and master degree in chemical engineering and a master's degree in biomedical engineering. Please welcome Dr. Kathleen Milbachler. Kathleen?
Yeah, thank you, Gerard, for this kind introduction. And it's a pleasure to give you today's presentation about our automation platform we're using on our twin column systems. Again, the topic of today's presentation is give you a short introduction of the system, of the hardware used in the automation, our control software, and show you an overview of our HMI screens and how our control strategy is implemented when you're running our twin column systems. At the end of the presentation, I will summarize everything and there will be time for questions from you. Our twin column platform includes a benchtop system and our scale-up system for the twin LPLC, which can be run capture, sequential, and batch chromatography, but also our HPLC version, which is for the MTSGP application. Again, today the focus is on the process control systems for the twin technology. We have other webinars which go more into the details of the systems and of the process, but I want to focus now on the control strategy. Just a few words about our system, and here I'm focusing on the low pressure system, but similarly can be applied to our high pressure twin systems too. We have multiple pumps on the systems. In case of the low pressure, the EcoDOS pumps from Lever, which have digital motors. Our systems have multiple outlet ports with fractionation valves, have multiple inlet for each of the pumps. We have directional valve blocks on the systems, which are crucial for operating the process. Each system has at least 2 column valve blocks, which enable the bypass, but also up and down flow on the columns. And we have multiple PAT application, like standard at the outlet of both of the columns, UV at different wavelengths, pH and conductivity, HPLC. However, we could also implement pre-column analytics to the systems. On the right side, you see our panels. In case of the low pressure application, we have divided panels. The lower panel is for the controls of our motors, and the upper is for the PLC and for the HMI and the IOs of the systems. And you can see here a good view of the HMI in this case. Our next slide will lead us now to the hardware, and this is everything which is essentially in the panel, and you see here a picture of the inside of the panels, and it's good to see all the IOs, the controllers, and on the left side you see a blink of the HMI from the back side, the HMI computer. So if we're looking again on the front, you see the panel with the HMI monitor. It's a touchscreen. Behind is a PLC computer in the panel. We have the controls on the front side and indicators. I will speak about this in a moment. And the front is, on the lower is a main power switch, which can disconnect the system from the electric power. And again, on the bottom is the control panel for our motors. The panels are closed by key locks, so we ensure that there's no access to the electrical power. In case of high pressure systems, the panels are purged with air to ensure the electric codes for the applications. Again, now I closer look at the controls and indicators. So you can see in the front for the low application, we have USB ports or an Ethernet port, so we can connect to the PLC and the HMI. We have an emergency stop. There's a master reset button and alarm indicator, and also a signal on the panel which will make loud noises, annoying loud noises, so you ensure that you hear the alarms. Also, you see here a picture of the main power switch, and this one has to be engaged to the on button so the system can power up for operation. Here's just a scheme of our system. So we have a PLC in the panel. It's an Allen Bradley PLC unit. We have also an industrial-based PC HMI system with touchscreen and the option of a remote keyboard and mouse application. The HMI is our primary interface, but we could connect secondary interfaces, say, in an operator room. The system has data acquisition and storage capability, and the computers run on the Rockwell platform, the factory talk. We have alternative made application in DeltaV control system. All components of the hardware are industrial standard components, so they can be serviced globally around the world. And just here, one view, there is the traditional field instruments which are on the skid, so that that's the IOs and the PAT coming into the system, and the controller from the motors here displayed on the right side. Okay, that is all to the hardware, and I'm switching now to the software architect of our systems. Just a brief overview. We have a recipe-driven control software which enable 21 CFR Part 11 compliance. We apply now in our second generation a graphically driven recipe building capability, which enables the application of parallel running multiple application at the same time, implemented in the sequence templates. Our systems can run traditional single column batch chromatography, sequential application, but also continuous applications such as the capture step or the MTSCP step. I focus today mainly on the capture, but if you have interest, I can go separately into the MTSCP if you contact us. We have in our system implemented alarm and event recording. Those are logged in the event log and can be recalled in the reporting structure. We have a user user groups with different access to the system implemented. The system can be run manually for setup or for service application. We can run semi-automatically when you want to test, design your recipes, and of course for production you would run the system automatically with recipes. Our recipes and sequences have hold buttons, restart up and stop control, and our system control system is standalone standard, but can be implemented in your company's DCS system or MES systems, which you have on site. Okay, I go into more details. As I mentioned, we have standard user groups which have a predefined access to the control software. You know, your operator can start, stop, halt, run, or sequence, can acknowledge prompts and alarms, can run the batch reports, and configure the trends, and you will see that later in the presentation. An engineer, your PLC engineer or engineer can also can do everything an operator can do, but also can configure recipes, store the recipes, set the parameters, stop the operation. And as a highest level, there's the YMC engineer, which has like all the functionality for configuring the system in the preset up for your application. And then, of course, there's administrative, which can manage the the user accounts in your system and monitor the user access to the system. And of course, a guest account for just monitoring what is going on the HMI. You will see that in a minute. The structure of our software is built of different levels, and the lower levels are pre-configured from YMC, from our software, our automation department. So the lowest level are the control modules, which include all the IOs and digital or analog input and outputs of the systems. All valves, all motor settings, all PAT settings, and they are pre-configured from our automation department. We are also summarizing the IOs into equipment modules, which include like the pump inlet valves. So there one equipment module, flow control modules for the pumps, or also control modules for the columns and modules for the outlets. This is all pre-configured, and they are very similar across our entire platforms. So you won't see a difference between an LPLC system, our twin systems, our HPLC system, very similar design. Now we come to the next level, which is for our users. That includes the sequence templates, which are designed, pre-configured from our automation department for the process application, and you use the sequence templates for designing your recipe as the highest of the structure. Just as an example here, I show you here our standard kind of sequence templates. So there are sequences for setting up your recipes, where you can prompt switching on your UV lamps and identify if you want to be prompt, you can have prompts for your process runs, what kind of packing material you're using. Then there are sequences for priming your inlets to ensure all the buffers are on the pump inlets. We have standard sequences for flushing the system, which could be used in the recipe, not only for flipping buffers, but also for doing CIP on the skid. And they have controls, so you can ensure that a particular pH or conductivity value is reached. We have the standard process sequences, and they might be varying depending if you're running a batch process or a continuous process for capture or for the MGSGP process. But each of these sequences has standard functionalities, and they are including also for the elution, how you set up your elution based on time, on UV, or on maximum peak height, for instance. We have standard sequences for gradient, so you can implement linear gradients or step gradients. And there are standard sequences for collection. So depending how many outlet valves you have available, so you can choose how many positions. Our standard system has 6, so you can have up to 6 peak fractionation or fractionating multiple peaks, or you can do your collection based on UV or volumes or time, depending on your choices you make in the templates. We have also standard sequence templates for column evaluation. So if you're implementing a new column on your system, you can determine the plate count, the asymmetry factor, but you can also go back to your columns and re-evaluating after a run or before a new run when you reuse a column. We have CIP flash when you have the automated CIP manifold on your skid, and then you set up an automated CIP. And we have the sequence for open loop tuning, which is more a configuration function when you're doing maintenance on your column, so you can recalibrate your pumps for the system. Okay. As I mentioned earlier, we have also different status for recipes. So when you set up a recipe would be in a development status. So you can configure all the sequence templates, you can test them. This is done usually by one person with the appropriate access levels, and it does not require a second person verification. If you put your recipe into production mode, this transfer requires second person verification, but also the execution of a production mode recipe requires second person verification in the execution of the recipe, and you will see that in a moment. And then you can take your recipes and you can, if you don't longer need them, and you can put them into the archive status. They will be saved in the database, and you can call them up and use them as a template for a new development recipe, and we would rename your recipe so there is no conflict there. So just a brief overview of the recipe statuses, and that brings me now to the HMI of our system, the human interface. Okay, we have a very user-friendly system. As I mentioned earlier, we're using the Rockwell Factory Talk, where you can have trends, alarms, and column manufacturing tools, and I will explain them in detail in the following slides. But you can implement control strategies for the capture step. We have the automap, which has been or is explained in separate webinars, or the M control strategy. Again, it's a user-friendly, as you will see in a few minutes. You can access the HMI remotely and operate your system either from a secondary safe location or from any place in the world in entry to the HMI. Our control software has an integrated historian, PI historian, where the data are saved. And also we have a report capability, and these reports can be customized by the user. Okay, so when you start up the HMI or the system, you will come up to the YMC process technology login window. And so depending on the user group, you will log into the system, and that will then give you access to the screens, depending on your access level. I assume I log in as a YMC engineer at this point, so I will have access to all the windows. If an operator logs in, they will have limited access. So again, that was your login. So that will then open the main HMI screen. And here I was signed in as an engineer, so I might have access to most of the screens. And just pointing out the main component of the main window. This is on the upper left side is the status windows with a login, and it gives you an overview of if all the power is in place, the e-stop is not engaged, you have the air. So if there's no red sign, you can operate. We have also a little camera upstairs, so you can always take screenshots. The middle part of the upper HMI screen gives you information about the active sequence which is running in your recipe, or if you run just sequences separately. And the upper left side gives you information about the current running recipe. On the bottom, we have now the other windows available to the users. And again, depending on your access levels, you can access different screens. I'm highlighting here the trends, the recipe editor, run, sequence, report, the column management, and the totalizer, alarm and alarm history, and the engineering screen. I will go through each of these screens in the following presentation briefly, so you will have more insights there. But you can see that on the HMI screen, you have all the components, main components. In this case, we are showing here a 3-pump system, 2 pumps delivering a gradient for the capture SMB step, and the third pump, the B pump, is for the supply of the feed in the system. You can see the pumps, the inlet valves, the flow meters, which are in control with the pumps. We have information about the columns attached to the system. You can see all the valving and the PIT or pressure indicators. In this case, we have only post-column PIT, pH and connectivity, and UV. And you can see the column valve block with forward flow, backward flow, and in this case, the columns are in bypass. And here on the lower right side, you see the outlet valves. And the next screen is, as I indicated, the trend screen. The main screen, of course, shows you the trend. You can configure the trend. You can indicate if you want to run your trend live when you push this button, or you have a static screen. You can overlay different trends if you want to save, zoom in. What you're familiar with. On the lower left side, you see here a list of tags. So you can add any of the tags I mentioned earlier, the pressure indicators, the UV signals, to your main screen, and you can modify if you want to have an auto adjustment, or if you, in this case, you have a max and a min value in the display. And you can, of course, there's multiple aspects. You can change the colors if you want to. You can change the time window. So you have a lot of functionality. This is the integrated data from the Pi historian. So you can export your data to a separate CSV file and open then the data then also in an Excel spreadsheet, for instance. That runs continuously while you're operating the process. The next slide I want to show you, and again, we have a separate webinar which goes in more detail about the trend. I want to highlight here the functionalities of the sequence screen. As I mentioned earlier, we have predefined templates. You see on the right side the equipment modules, which are usually only accessible for our YMC engineers, and they're important when you configure the system for the application. But you, as a user, you will only have access to the templates for, in this case, on the left side for the batch operation, or in the middle we have the templates for the continuous capture operation. And you can open these templates, and you can test them in a kind of semi-automatic fashion. I will speak later a little bit more about this. We have a Totalizer screen which allow you to follow the operation. So in this case, you can follow if you have reached a target for the pump A and C of 0.1, and you see we have not reached it yet. You can also follow if you have a analytic requirement. You have process steps, Totalizer, and you can also follow if your product, as you have defined it, has reached the collection volume you defined it. So that is easy to follow your progress on the Totalizer screen during operation. We have also a new tool which makes it easier and simpler to implement columns into the system. As you can see here, there's a button, add new columns, and then you can add information for the columns, the ID, the packing material, resin information to each of the columns, and then you can install them onto the skid or uninstall them in an easy fashion. And all the columns are stored in a separate database and can be recalled as you need for specific applications. As I mentioned, also we have an event log where everything which happened on the system is logged. That includes alarm, and it also includes the login of the users. Now I'm logged in as a YMC engineer, and that would be visible on the event log. On the alarm historian, you see in this case an alarm came up, and you as a user, as an operator, when you push on the right, on the upper left corner, and then comes up an acknowledgement window, and you can then add the reason why the alarm was there and acknowledge that you have seen the alarm. In case of an alarm, it will show up in the screen as a red line or a red alarm. If you have a warning that you come in a low or a high value, say of a set flow rate range, then that would show up as a yellow line. But you also have to follow the same procedure of acknowledging it. I come now to the last screen, the engineering screen, and this is mainly used for configuring the system, so for our YMC engineer, but also your service engineer will have access to this screen. And so if you need to do a new pump tuning after a service, then you can run the pump tuning functionality. I want to also point out we have the report configuring point here, and I want to just highlight here in this screen the reports. Your batch reporting can be pre-configured to your needs. Also the recipe, the cycle reports. And we had a separate webinar where we went into more detail about how you configure the report. I have to refer due to time limitation to this webinar. Okay, how we operate. So you have seen now all the screens we have in our control software, and I just wanted to give you a brief introduction how to run the system manually, semi-automatic, or automatically with the recipe. So in case you just have the system new in your facility, or you just bring it back after storage, you can set up the system manually, make sure the lines are flushed so there's no air in the system anymore, and you can do that manually. You can push the buttons of the pumps and the valve and transfer them from the auto setting to a manual setting, and then define the parameters. And you see here in the background that then the open flow path is highlighted in green, and any valve which you have open in this case has a little indicator on top with an M, and that indicates that it was manually shut open, and you can see that here on the outlet too. And if the flow path is open, you can now flush the system manually. It is also something after you do a service, you want to quick check that everything is okay. The system also can run just by recipes, and here I show the column evaluation template. So you go in the sequence screen, call up the column evaluation template, and then push the parameter button and define the parameters. You can also use this functionality when you want to set up your recipe for the recipe run and just test parts of the recipe, a sequence, to see that everything is set up exactly, so you can run a separate sequence by itself. But of course, for your manufacturing process, you want to run the recipes. And we have a separate webinar which goes in really detail how to configure and execute the recipe. I just want to highlight it is easy now with the drag and drop functionality, so you can configure your recipe with the predefined sequences, and they are now predefined for your application. So if you're running a capture step, then you have to choose here the twin capture. If you have a batch process, then you have the option to choose a batch process here on the top and configure the recipe. And again, there's the option of running them in development and then transferring them into the production recipe. All recipes are stored in a database, and there is an audit trail for all the activities going on there. And on this screen here, you see all the templates for the continuous capture step. And okay, just a few items here. So you have the option when you create the recipe in the development state to do a new recipe just from scratch, or after you create the recipe name, you can duplicate an existing recipe and use it as a template, or you can recall a recipe from the archives. And here, just to show again the easy drag and drop functionality of our recipe builder. So you can see there's the function box, and you drag them over, and then you define them here in the field for the application you need with a sequence template. Very easy to implement. And in this case, you can see then when you click and define the parameters to your process needs. again, I can't go into detail how to define. I just want to highlight each recipe has global process parameters which define then the alarm settings for this particular recipe. So you have the high and low parameter set for the flow. You have them for the pressure, the delta P over the columns, for instance, and they will be then saved together with the recipe parameter for this together in the database. Okay, and then we're coming to the last screen, the recipe run screen. So you give each recipe then a unique run name, and there cannot be any repeats of the names. And you can then start your recipe here. And if everything is configured correctly, it will start the recipe, and you can then monitor the recipe. And you can see that here nicely, the active recipe, each of the, in this case for batch process, the sequence is highlighted, which is active. And you can see again here in the middle part, the sequence, which is active, shows up. And in this case, it asks you for a prompt if that is the right column installed. And you also see here on the right side, then the recipe running, and you have that now active on the screen. If we're now pushing the main button, and that is now for a capture step, you can also follow the progress of the recipe. In this case, nicely shown that we are loading now both columns, starting with column number 2 for continuous capture step, and then going to the second column here, and you can follow very nice the flow path. You can follow all the PAT on the system, the pressure indicator, and the post column PAT, pH and conductivity, and the UV for this application. And I show here you also for parallel operation. So the column, the pump A is feeding column 2, and pump B, the feed solution, goes on to column number 1, and you see the parallel outlets. And so it's a very good tool to follow the operation of your process. Also, you can again look at your trend screen, and you can highlight the information you need to have monitored. So in this case, I'm following the flow and the UV signal and my outlet valve, so I can monitor that the product, the peak, is collected in the time window I want to. And I follow the different flow rates on the system. So this is the loading flow rate of the pump B, and you can see here in parallel operation, and while parallel run is here of pump A is loading the column in this case. Okay. And again, if you want to know more about the trending, I refer to the separate webinar we have given. And at the end, just quickly, I want to summarize. If you want to generate reports, there are different options you have available. After you wrote your recipe, you can generate your recipe report, can compare it with your requirements, and in case of a development report, you can then update the parameters if it needed. And then transfer this recipe into a production recipe. And again, you can, as a proof, print this recipe report. After you're running your process, you can then print your batch report, which in case of an continuous report is a very long report, could go over days. So we provide you a third option where you can print a report after each elution and have the adequate information you need to monitor your process. So just push the button, create report. Again, we have a separate seminar where we go in more detail. Just an example of a report, that would be the front side, and you can configure the report. The generation of the report is depending on the amount of information in the report, but could be within seconds. You can have it at hand. you can modify or adjust the report structure, as I told you earlier, but each of the PDF printed has a timestamp, and you know exactly when it was printed. And you can have in the report, besides the recipe information, also information about the performance of your process, like you have peak analysis of each of the elution peak in case of a continuous process, or a transition analysis if you do that during continuous operation. And just, I want to summarize at this point and refer you to the other seminars for more detail. And I hope I could present you a comprehensive overview of our automation platform, which is compliant to 21 CFR Part 11. And it is an engineering application, and it can be used for development and production. It uses commercially available component, which we configure to the application needed. And so we enable you as a user to have recipes for your application. Thank you very much at this point, and I would like to give over the presentation to our moderator, Gerard, before answering then the questions. Thank you very much.
And thank you very much, Kathleen. That was an excellent presentation. Since 1980, YMC has been a leader in chromatography, producing bench and prep scale HPLC and LPLC systems, packing resins and columns. YMC is a global company with manufacturing and offices in over 10 countries. Just a reminder that other aspects of this topic are covered in focus webinars available on YouTube. Just go to YouTube and search on YMC Process Technologies. Okay, I'd like to bring back Kathleen for Q&A. We do have time for a limited number of questions, so let's get right to them. And the first question is, Kathleen, you mentioned Capture SMB and MCSGP. Can this software operate both of them on the same system?
Oh, we have the MCSGP as an HPLC skid. So that would be different software packages to use. And we, as I indicated in the presentation, we have a lot of overlaying functionality, but then the sequence templates are specified for the application.
Very good. Is this open source software?
We're using commercially available software packages from Allen Bradley or Rockwell's a factory talk. However, we configure, as I have hoped I could show you in the presentation, we configure these available functionalities to the application. Plus our application, the MCSGP process, for instance, is patented. So it's not that you can access the code of the configured system and modify them. So it is, no, it is not open source.
Next question, what happens to my data if I have a power failure?
Okay, in case of a power failure, we have an included USB functionality in the system. So while you're running your system, everything is logged in the historian. So that is instantaneously. There's no significant delay in logging the data. So in case of a power failure, so the whole system is down, is a USB functionally brings it down to a safe place and logs the data, which were the last one, and the recipe, everything is there.
Okay. Final question.
Okay.
You mentioned 280 and 300 nanometer. I'm assuming this means for the UV wavelength. Can you modify to other wavelengths?
So it's depending on the application. So generally speaking, a capture application on LPLC in that field would run for a monoclonal antibody in this wavelength. However, if you're running another application, we have the choice to select different wavelengths in the application. So our suppliers of the UV sensors provide different filters so they can be implemented. Say you needed 254 for your application, that could be done. The other, in case of a MTSCP application, we using available wavelengths. So you can then set the wavelengths to the application, and you have the right range of wavelengths. You can choose it, and then you have your wavelengths. So depending on your application, but there is some flexibility. You don't need to just use 280 and 300.
I want to thank the audience for your questions. For those of you who have an immediate application or a further question, you can reach out to us at info@ymcpt.com. That's info@ymcpt.com. I want to thank everyone. We'll end our session now. Thank you and have a good day.